I might not actually fit this all in half an hour, but I will attempt to do so. So, hello everybody. This is AGL and Yocto Project 6.0. I'm Scott Murray. I've been using Linux for a very long time at this point. I've worked on embedded Linux for, I guess, over 25 years now. And I worked at a consulting company called Konsulko Group since 2014. And we've had a contract where that's had me on AGL since 2016. Which I help out on Yocto project maintenance, a lot of the development, demo development and integration, and maintenance of various odds and ends throughout the tree. In the last couple of years, I've been also maintaining the Rust mixin and meta security layers for Yocto. So kind of now some more wider community stuff. So our agenda on this talk here is I'm going to talk about Yocto Project 6, and I'll kind of go into the work that we've been doing the last couple of years to get here, talk about some of the new features, and give the current status and our sort of future direction of things. So what is Yocto Project 6? It has the lovely to pronounce codename Wrynose. It is the spring 2026 LTS release of Yocto Project, which was supposed to be, I guess, officially announced last week, but it slipped into this week. So it was yesterday the official announcement email went out. It's right from the get-go. It's listed as having support till 2030, so April 2030. And the support window does overlap the ScarthGap LTS, which its end of life is in 2028. And in AGL, we're actually going to still carry ScarthGap and the ultimate Yanagi branch until it goes end of life in 2028, which is similar to how we have been supporting Kirkstone with the Quillback branch. So what is Wrynose? So this is actually a picture of Wrynose Pass in the United Kingdom. So Richard Purdy, who's the maintainer of Yocto Project, he lives nearby these what's called the Lake District in the United Kingdom, and so he's been using names of different passes. So a little bit to expand on that is that, all these code names for the releases have been coming from places in the Lake District, and he's sort of run out. And so the next release name is still actually marked as TBD in the website for Yocto. And Richard has mentioned that he does have some more Mountain Pass names he didn't use, but if he were to put them in now, it would break the alphabetical ordering that's been sort of somewhat consistent the last few years. Or he could just pick a whole new scheme altogether and switch to some other set of code names. So we'll probably find out in the next month or two, I suspect, because people have actually started bugging him about what the next code name is. So that's what Wrynose is. This is, Yocto Project LTS. So, this is a little bit of how we've been working to get to it. So we merged ScarthGap support, which was the last LTS, in April 2024 for Ricefish. And so what we call the next branch in AGL is where we tracked Yocto Master, basically. So start the evolution towards the next LTS. And so the next branch, it's not updated like super frequently sometimes, but typically when Yocto Project does an interim release, we do match it relatively soon just to kind of catch up. And I gave a presentation last year where I went into sort of all the interim releases and a lot more about the process, so I'm not going to cover that. So here are the interim releases between ScarthGap and Wrynose. So they have these names that I won't attempt to pronounce, some of them actually, because I typically get at least one of them wrong. But basically every 6 months there's a release. So, this is in those in-between periods, there's sometimes quite significant changes on upstream Yocto that we have to sort of consume. And so basically, like I said, within a few weeks of them doing a release, we'll probably, be updated. And if you track the next branch, you'll see that, over time, we're sort of, as, time permits, I kind of update it. And, the big benefit to us is we catch things early. And so sometimes we have to actually talk to upstream Yocto folks to kind of, ask questions or say, well, this isn't really going to work for us, and kind of give feedback. And so the discussion, I sort of gave more details on this. Here's the links in the presentation to the talk, basically, from last year. Okay, so, Wrynose, next LTS, what's in there? And so there are a bit more details in some of these things in the presentation from last year, but this is sort of the high-level overview. So if you have to write bit-bake recipes for software, the really big thing is these first couple of bullets here is there's this new unpackter variable that affects about how your source gets expanded, basically where it goes when you're doing a build. And the S directory, which points at the source tree of a thing that's being built, is also some changes around that. It's gotten a little stricter about white space around variable assignments in recipes. And at the distro level, there used to be this debug tweaks thing that was really convenient for developers, turned off basically passwords for root and stuff like that. They've sort of made those a bunch of separate features to make it more explicit that you know what you're doing. When you, debug tweaks is sort of a generic term. Now the flags are like allow root login and no root password and stuff like that. So it's a little more obvious what you're doing. Another big change that's somewhat recent is systemd is now the default in Open Embedded Core, but the Pocky distro from Yocto still actually uses sys5 in it. So where this comes into play is if you're basing your own distro on top of Open Embedded Core and not using Pocky, if you want sys5 in it, you have to actually turn that on yourself. The host tool requirements is nothing too dramatic here, slight bumps, one version newer of Python on the host machine, and GCC 10 basically as now sort of the new thing. And here's a list of the distros that are supported. I updated this yesterday. Basically, this is sort of what you expect, or these are distros that most people would likely be running. A change from ScarthGap is actually now we have 3 different Ubuntu LTSs. ScarthGap, I think, only had 2. So I think some of this comes out of the Yocto Project Auto Builder has sort of expanded its coverage. So now they test more things. And if you're on another distro that isn't in the list, you can still use the build tools tarball option, which basically gives you a pre-built set of the host tools, and you can sort of make it work on a distro that the Yocto project doesn't test. So that's still there in even now. So another big change, and this is a hot topic these days, is for SBOMs, SPDX v3 support. It was added initially post ScarthGap. It is in Wrynose, of course, but now it's actually most of it has been backported to ScarthGap. There's some. It's hard to call them minor, but there are a couple features that require more dramatic backporting that they haven't done. So if you want full-blown SPDX v3, upgrading to Wrynose, if at all possible, is in the near future would help you. But then the sort of corollary to this is that v2 support has actually been removed recently, which that might upset some folks in the short term because people are building tooling around that. But the arguments for it on the mailing list was, so Wrynose is going to be supported for 4 years. The maintenance burden to keep v2 working well enough that people might still use it is kind of viewed as too high because there's features in v3 that the folks who are implementing this stuff in Yocto are like, well, if you actually have to productize shipping SBOMs, you need v3. So it doesn't make sense to support v2 because we should push people to v3 because they're going to realize sooner or later they need it. So you might disagree with this viewpoint. I'm not an expert enough to really give a strong one way or the other. And so one of the other arguments is that tooling exists that you can generate v2 JSON files from v3. So this is one of the tools that's out there. I think there's probably, we'll find that there's some more if you actually need one. The other sort of big change is sort of in the same space is the CV checking support has been quite significantly redone. Some of this stems from data sources becoming unreliable and folks wanting to have multiple inputs for basically CV data, which the CV check BB class, it was really getting hard to keep adding stuff to it. And the other thing was, if you've ever run this, is you basically need a full build tree you don't necessarily have to have built, but you have to have the full tree set up and all the source fetched, which isn't convenient if people are going to need to do checks a lot more frequently now. So basically now, Bootlin have this tool they call SBOM, CVE check, which is sort of flips things around, and it actually uses basically SPDX SBOMs as input, and that's been integrated to replace CVE check BB class. So now the CVE checking in Yocto actually goes in the direction that, it does use SBOM CVE check when you build an image, but you can also then take the SPDX file you get for your image and check it later with SBOM CVE check. And that's basically the direction folks kind of need to go to be able to do this stuff after they've shipped something as a product. So that's another big change if you're in this space. Another sort of thing that's been dropped is the NPM fetcher, which if you build any kind of node-based project with JavaScript, basically you're going to find those recipes no longer work. The fetcher has been disabled in BitBake, and so the argument as to why that was done is there have been a lot of these supply chain attacks made against NPM, and the Yocto fetcher didn't have checksum support. And so it's actually giving you an illusion of security, because if you were to BitBake a recipe using this, it would fetch the new packages. And so it's not stable and reproducible, and it opens you up to suffering from the poisoning of a supply chain attack. And so it was decided that it's better to just not let people fall into this trap, even though we're actually they were removing that functionality. There has been discussion about building a new fetcher. I'm not sure if it would get backported to Wrynose if it happens, maybe. But it would absolutely have to have per package checksums the way the Go and Rust support in Yocto works today. So that's complicated enough. I suspect it's not going to show up like tomorrow. It's going to be several months before someone actually, I think, pops up with a new fetcher. The other sort of new feature that is sort of probably, if you follow Yocto much, you might have seen some press around this, is there's a BitBake setup tool. So it has been in development for, at this point, I think roughly a year. And now with Wrynose, it's considered feature complete. And so it basically is a layer setup and like BitBake configuration generator. If you've ever used CAS, it's sort of in the same space as CAS. It has some differences about how things work, but it's kind of in a similar tool. The difference that sort of makes it a little more unique is that it's part of BitBake. The BitBake setup script is in the BitBake repository, and the Yocto project is using it for all its CI and stuff like that. So it reuses the BitBake fetchers, so there's some good synchronicity there. And Jan Simone has done some evaluation of it, and he's going to have a bit of a talk about it on Friday in the workshop. So not going to go into huge detail on this because I would take more time than I have. So some of the major things that I suspect people might be impacted by. So basically we're going from GCC 13 to 15. LLVM and Clang are basically going from 18 to 22. glibc is a little more subtle. 2.43 actually has some significant changes that, at least throughout the Yocto tree, there was a bunch of little minor fixes. Go basically is basically that 4-year jump, and Rust is the same. Although Rust, you'll see like the Go is basically 4 major versions, and Rust is a lot more because they release more frequently. Few specific things. So GCC 16 actually just came out, but it was too late. And that's happened with ScarfGap as well. It's just the release cycles don't align. But we will see, probably I suspect in the next 2 months, there'll be changes probably backported to Wrynose. If anything needs to be fixed to support having a build machine that has GCC 16. It's almost always the case that something needs to be fixed for that. That would probably be if you're running like Debian Unstable or Fedora. It's always the case, these bleeding edge distros that have the latest things, the LTS for Yocto project eventually stumble upon something. And like I said, that's very similar to ScarthGap and GCC 14. Another big change here is that GCC now defaults to the C23 standard instead of C17. And G++, I don't think the default has changed. I think it's C++ 17 or something like that. But the 23 and 26 standard support has been improved. I think 23 is considered roughly complete, so if you need fancy features that might be there. There, of course, again, if you've ever had to live through a GCC upgrade, there are new errors and warnings. But this time I didn't find that too bad. We had some very minor things in AGL that we had to fix. But if you have a big code base, you probably will find some stuff. Clang is actually a little more substantial in that you used to need to use the meta Clang layer. That's actually gone away now. Clang is actually part of Open Embedded Core. So if you clone on Open Embedded Core and meta Yocto and set up a build, even with plain Pocky, you basically have Clang as part of the tool chain now. And this was driven by Meza. There's a few graphics drivers now that won't build unless you use Clang. And so in specific recipes now, if you have a package that will only build with Clang, you can say toolchain equals Clang, and that works with just straight Open Embedded Core. And so that's pretty flexible. It's been a long time coming. I kind of hoped this was going to make ScarthGap, so it's good that it's in now. And like I said, meta Clang now is almost redundant. I think it will be made completely redundant in the next year. There might be some corner case if you have some like odd layers that are slowly maintained. There still might be a need for it. But we haven't needed it in AGL on next branch, so I've removed it. So Rust. So Open Embedded only carries a single version of Rust, but Rust moves quickly, as I mentioned. And so you can be somewhat at the mercy of the upstream Rust ecosystem. Crate developers can bump the minimum version of Rust they need on you, and so you might, do a cargo update of your Rust-based application, and all of a sudden you need a newer version of Rust or a bunch of hacking. And so that's, right now that's considered outside the scope of Yocto handling that, at least directly in Open Embedded Core. And so the way to work around that is what we are called mix-in layers, which for Rust I maintain. So for Kirkston and ScarthGap, there's basically a layer to backport the newer versions of Rust. I don't think anything's going to change in Wrynose, actually. And so expect sooner or later a Wrynose mix-in layer. Hopefully not super soon, but we'll see. So Linux Yocto, which is the kernel provided by Open Embedded, it was 6.6 in ScarthGap. So basically it tracks the LTS kernel, the newest one as the time of release. So right now it's 6.18, so that's what Wrynose has. And that matters for us because we use it to build things like the QEMU images, things like KVM and Zen. It's the guest kernel. And so now that the LTS kernel upstream, the default, when they do a release, they say it's 2 years. That's sort of become a little less set in stone. And so there is a chance that the Linux Yocto version might change during the Wrynose lifespan. But now, because the 6.6 kernel end of life got pushed to December 2027, it's not clear whether they'll bump Linux Yocto and ScarthGap. You'll notice that, December 2027 is still before April 2028. But I'm not sure if they'll bump the kernel to cover that 4 months or not. So we'll see. It's still up in the air how that's going to go. glibc, the 2.43 glibc, the minimum kernel is now 5.4. But as far as I'm aware, it's unlikely you have a BSP layer that has a kernel that old, hopefully. Maybe there might be some crazy Android-based stuff that if you have an Android kernel, you could be stuck. But all our BSPs have new enough kernels that that's not a concern. So here's some other notable packages. I won't go into huge details here. I'll pick the specific ones. So Weston is always fun for BSP maintainers. Weston 15 is now what's in Wrynose. I actually had to push that upstream. And for, I guess, systemd has a somewhat significant jump there, and Meza. So I'll just try and quickly get through this. I have 9 minutes. So systemd actually now is starting to drop the System 5 and its script support, which is, there's magic in systemd that if you have an its scripts, it'll make sort of wrapper units in systemd around them. That's going to completely go away by the time we do the next update and to like the next LTS of Yocto. So it's marked as deprecated now, and I think it might warn in the logs about that. So if you're still kind of getting by with some init scripts and relying on systemd to magically do stuff, it'd be better to start migrating away. Systemd now actually wants a 5.10 kernel. I think you can work around that if you have to, but hopefully you don't. cgroup's V1 support is now completely dropped. We've had some things like the instrument cluster expert group have had to work around this a bit in the past. Now it's completely the case that new systemd will not work with cgroup's V1. Another thing that I hope you don't use is TPM 1.2. Systemd has stopped supporting that altogether. Hopefully you're using TPM 2.0 based hardware now. But if you're not, this might cause you some pain. And there's a very long change log for systemd that if you're more interested, you can go through. Weston, the Weston 15 gets us what's called the Lua shell, which goes in the direction of allowing you to basically customize a shell for Wayland using Lua. There's an example, I think, that implements a tiling window manager sort of base sort of thing there. So if you're interested in that, and I think the reason it was added was to sort of start working in the direction of replace might be too strong, but at least give people more flexibility than maybe AGL Compositor is giving at the moment. So that's, if you're interested in that, we have that in we might be able to play with it. There's also an experimental Vulkan renderer. This Perfetto profiling support, which is kind of, if you have a project that also uses Meza, Meza has full Perfetto support, so now you can kind of trace all the way across your application layer and the GPU driver. Better HDR color support, and Marius wrote a big blog post that has even more details, so if you're interested in that, you can kind of skim that. And so I mentioned Vulkan. So one of the changes I made in the next branch that we're going to pull in when we merge is I've enabled the distro feature for Vulkan, which doesn't mean that it's magically on for everything. It just means that the support is built if the BSP layer is using that conditional flag to turn on stuff. And some of that is because there's actually some hardware that I got that we have where the Vulkan works a lot better, actually. So right now, the visible change is I've set things up to build the Flutter embedder to use the Vulkan backend on the Raspberry Pis and the Nano PC T6, which is the Rockchip hardware. And if other BSPs are, we find out that the Vulkan support is usable, we can start doing more in that space. And there's still some room for experimentation. I haven't tried it yet. The Weston Vulkan renderer is something we can experiment with as well, because AGL Compositor is based on libweston. So I'm actually not doing too bad. I have over 5 minutes left. So that's the features kind of laid out on the major changes that we're going to be consuming. And so, since the end of the year, end of last year, I've been focused on more frequent rebases and a lot more testing. We didn't really want any big surprises. And so that kind of boiled down to this time as opposed to the Scarth Gap upgrade, trying to test more of the images, things that, not just the main demo images, test more variants and stuff like that. And some of the non-core demos lagged a bit on the last time, so we should hopefully be less of that this time, like things like the instrument cluster EG demo. The BSP support is not too bad. In addition to the QEMU machines, the Raspberry Pi and Nano PCT6 are working right now. I haven't tested the things like Freescale and stuff like that, like the NXP hardware, but the BSPs I think are okay. Really right now the outstanding are the Wrynose boards. But the Sparrowhawk, I've actually, I'm trying to remember, is it Hamamachi-san? We've been provided a like experimental branch to test, and that's mostly working. They have to get a newer kernel in to fix a perf build issue, but it's looking reasonable. And so I suspect we'll probably see the Wrynose stuff will be early June. We should have that squared away. And so saying that, basically, it officially was released yesterday. So our plan is to start merging it next week. So next branch, it's not drastic number of commits, but it's also non-zero. There's a bunch of them in Meta AGL. And so, start that process next week when we get back, and I'll work with Jan Simone and whoever else wants to review. And sort of this echoes what we did with ScarthGap. We were pretty close. Like we had it all merged within a 2-week period after the release upstream. And that said, if you do have a particular machine or dev board or a particular demo image, and you don't think that it's been tested yet, once we send out an announcement to the mailing list that the merge is done, please test. And if you hit an issue, send to the mailing list or jump on Discord, or other than that, you can file a JIRA issue, and we'll try and get things fixed up as quickly as possible. So similar to after ScarthGap, once we get the merge done and all the BSPs squared away and everything, we'll get back on the treadmill basically. And so next branch will basically rebase onto Yocto Master. It's somewhere, probably later in the summer realistically. And it's just, once we get all of the Wrynose issues fixed. But for sure, as we've done in the past, when the next Yocto release comes, which will be 6.1, which we don't know the code name for, we'll definitely get that merged, get enough changes in to make sure that builds. Because it'll have things like GCC 16. I think it'll have a new version of Weston again, because I think there's a summer release of Weston coming this year. And so there'll be some interesting things. And that's probably going to be like before the AMM in the fall that we'll probably see that some of this stuff goes in. So I did surprisingly well on time, actually. There's some more information. So there's another link to the last year's presentation and sort of some of the Yocto release information. And I guess I have maybe a minute or two for questions. I guess not. All right, well, thank you very much.